right? This is anti-lock brakes. This is some more of that. These images I use for your TEVES anti-lock brakes handout. All right, you got that part. Got the cluster. Got a sensor. Engine controller is part of the job. Look at that. What is that right there? What's the bottom right? What's number 5?
That's the brake stoplight switch.
Stoplight switch. What about that?
That's the hub assembly.
And that right there.
I've got no unearthly idea.
There you go. There's your little legend.
That's the front brake anti-lock sensor.
Anti-lock instrument cluster, warning indicator. They're showing you the whole instrument cluster. Rear anti-lock brake sensor, so on and so forth. These are all part of the system. All right. Now, pay close attention because we're moving ahead here. It's going to prevent wheel lockup. It's going to control the brake pressure during emergency stop. We all talk about when you lock the wheels up, even though you turn the wheels, you still slide in the same direction. You ever done that?
Oh yeah.
It scares the daylights out of you. And you wonder if you're going to crash and burn or whatever. Now, the amount of brake pedal force required to engage the ABS function will vary with road conditions. You're just going to need to know how fast you're stopping. A dry road requires harder brake pedal application to engage it than a slippery road because it's not going to slide the wheels as bad. See? It's going to have better traction, requiring more brake pedal force to lock the wheels. Now, what was really funny, I used to work over there, and I worked on Jeep Cherokees, and I worked on the Fords and all this kind of stuff. And there's a whole bunch of different configurations of anti-lock brake systems. Well, if you get out on a dirt road, like whenever I was wanting to make sure the ABS system was working right on one of these not Explorers, but Jeep Cherokees, you could get out there and stand on the brake pedal on a dirt road and it would go whoop, 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 whoop. It'd feel like a bucking bronco or something. Well, I got one of these little sports cars, little Ford Probe, you know, back when the Ford Probe kind of looked like a sports car. And it had, each sensor was like $200 for this thing. You've got to replace the brake sensor. But like I got on a wet road, it was raining a little bit, and it was a wide road so that if I locked the wheels up, it wouldn't be a big deal. And I got going about, 60 miles an hour, and I stood on the brake as hard as I could. And it was a slick, wet road, and it went, it stopped like there was like it was dry pavement. But I didn't ever feel much of anything going on. But I knew the ABS system was working. I could feel a little jittering under my foot. But long and short of it, you never feel any wheel sliding. But you see what I'm saying? It's either, on trucks and stuff, it's going to, it's not going to feel the same as it does on sporty cars. All right, this right here is your operational overview. Normal power braking occurs in this when the brakes are applied. These little words down here. Fluids forced from the brake cylinder, master cylinder outlet to the normally open inlet ports of the hydraulic control unit. So the inlet ports are usually open. I mean, if you just, everything's at rest, they're open. The brake fluid travels to the brake units just like that thing wasn't there. Just like it wasn't there. The stuff goes right on through it. If this is dead like it is on her husband's truck, then the normal brakes are working. So you're not going to rob you of your brakes typically. Now the one thing I have seen fail on ABS systems, over behind you somewhere there's a great big ABS control unit laying there somewhere. And it came off of an F-250 about like Quincy's, except it was an older model. And there it is right there. See it up there? Right there. Nope. Right there. That's it. That ABS control unit had to be replaced because it was keeping fluid applied at the rear brakes. If you did a panic stop on that thing, it wouldn't release the fluid that was in there because one of those solenoids was sticking. All right. If the driver gets into a situation where they're applied hard enough, it's going to determine which wheel is locking. It's looking at the wheel speed sensor, right? And it's going to send an electrical signal to the hydraulic control unit. It's going to activate the solenoid that controls the inlet isolation valve for the hydraulic circuit that controls that wheel. And that cuts off fluid flow. See that? Now, this right here, you notice this right here, how that's blocked right there? There's your isolation valve, and there's your outlet valve, right? So the fluid's coming this way. This wheel here started sliding. This blocks the fluid going to that wheel. And this basically is it's just basically keeping any fluid from getting there. Now, if that wheel starts to slide, this is going to dump some of the fluid pressure from that wheel, and then it's going to kind of hold it at the minimal. And as it starts to roll again, it's going to open this one and let that go in there. This happens in nanoseconds. It happens like, real quick. And so that's one of the things you need to recognize. You know, you can talk about this and see it, but unless you actually recognize the fact that it's happening really, really fast. How many of you have had an ABS situation where you hit the brake and it goes boom under your foot? Have you felt that? That's the kind of thing that's going on. After the pressure to the affected wheel is held, it reassesses its sensor signal. In other words, it's continually watching. It's seeing if it's seeing this little sinusoidal wave or whatever kind it's got on that Dodge Caravan we got out there. It puts out a square wave signal. What's the problem with using a sinusoidal wave signal? In other words, the one that makes the little camel humps. You guys all, most of y'all have done that worksheet where you look at the signal on the oscilloscope. All right. If you're turning that thing really, really slow, it doesn't do much, does it? You've got barely any hump at all. Well, on this Dodge Caravan that Jimmy drives, if you get over there and you look, it has a square wave. It's got the two-wire sensor, but they're Hall effect sensors. And what's really interesting about those is, if you want to see if they're working, you can just take your voltmeter and hook it up with the sensor, just back probe both of those, and when you turn it through, you'll see your voltage changing. You know, and I'm talking about DC volts. Now, if you're going to measure the regular ABS, like you guys are doing, you measure it with an alternating current setting. But on that van I'm talking about with the Hall effect ones, it's going to be and it's actually 7 to 14 milliamps is what it's switching. But if it's moving at all, that signal is going to be read by that thing. Here's something else you got to be watching for. I have seen situations where in some of the software and stuff you've got, you'll be going into your ABS system and it will report the right front as being the left front, or the right rear as being the left rear. So you're busting your fanny working on one that you think is not working on the right rear, and it turns out your scan tool is reporting the wrong one. So make darn sure you factor this in. You know, I've got smacked around by one of those. Actually, back when I was with Ford, the Worldwide Diagnostic System did that to me. It was telling me on a little Ford Contour that the left and the right, you know, the left one wasn't working and the sensor was good, and I was scratching my head. It turned out the one on the other side was the one I should have been working on because the tool misreported it. And I've seen that here too, using the Genesis. You know, the affected wheel still decelerating too quickly. The ECU is going to send a signal to the HCU, and it's going to open the normally closed outlet dump valve for that circuit. So basically, it's going to let fluid off. Like I said earlier, I kind of jumped ahead of myself on that. Just blocks it, and then it bleeds it. Blocks and bleeds. Got it? So outlet valve is going to bleed off pressure that's been trapped there. Inlet valve keeps more pressure from getting there. You understand that? You get that? You understand how that works? Pay attention to your test. You may be seeing some answers here. Okay, brake pressure decreased. That relieves the applied pressure from the brake. And once the affected wheel comes back to an acceptable speed, it's going to return the end of the oscillation valve, and they're going to open back up. And that's going to allow the brake fluid to travel the brake units once again. It wants to let it stop normally. It doesn't want the wheel slide. That's the point. That's going to repeat until the brake can be applied without risk of wheel lockup. And obviously different traction. If you got a really good pavement out there, you're not going to slide the wheels as easily, you know what I'm saying? Or if you got a dry pavement and good tires. Brake fluid released each time the outlet dump valve is open. There's got to be a way to replenish it, and that's accomplished by using a pump and a motor. That's what your pump and motor is about, in case you were wondering, right? There's your pump and motor. If it's running, see, it can actually put pressure in that system along with it, along with your pedal. When the pump motor is running, brake fluid stored in the accumulator, it's pumped back to myself. See that accumulator right there? An accumulator is going to be a piston with a spring behind it. So basically it's going to store pressure and all that. Okay, here we go. Let's look at this. That's what happens. All right, brake pedal's pushed. This is a normal stop. Brake fluid pressure activates the calipers in the drums. They're activated. It does not sense wheel lockup. They remain activated. Vehicle stops. That's how that works. Got it? All right, this is what happens when you got an ABS. Same thing, up to a point. Activated, wheel lockup. Sends a signal to the normally open inlet valve. Remember that? Inlet valve closes and stops brake fluid pressure from going to the brake cylinder to the calipers or drums. All right, this is where I didn't have room to stuff all that on one slide. Senses that wheel is still in danger of lockup. Sends a signal to the outlet valve in the hydraulic control unit. Opens and relieves the pressure. So you're going to let the pressure off. And then it monitors wheel speeds, and it might continue to turn them off and on, like that right there, to their normal positions. And then they're activated again. See how that works? I just built this Friday, so enjoy it, okay? The ECU determines the drive wheels have lost traction during operation below pre-programmed speed, about 35 mph. Listen to this now. Sometimes you're going to hear a car, when you drive off, you're going to hear it run the pump when you hit about 20 miles an hour on some vehicles, not on all of them. You ever hear that on yours, Moody? When you're driving away, you may hear the ABS pump go boom. Just it tests itself. It's constantly watching. Something else that happens that they don't talk about on here, when you turn on the key, the engine controller, not the engine controller, the ABS controller doesn't have anything energized anywhere as far as it uses a ground signal, Turns on that relay, voltage goes out to all of those sensors and solenoids and everything it's got on it that it can use. And since it doesn't have anything energized, it looks for that voltage to come back. So you got a loop, right? Got me? If it shoots voltage out there and it doesn't see it come back on that loop, it knows you got a bad something out there. And it's also your code for a solenoid or so make sure that's what you would do. You'd flip on the light switch and you'd see if it came back to you. That's pretty much how it's going to do that. And that's just a standard procedure. Your engine controller does the same thing. Electrical signal. This is traction assist. Got me? Isolates the drive wheel from the non-drive wheel. What happens when you get into mud? How many of you guys have ever seen my cousin Vinny? What was she talking about in there? She's talking about if you get stuck in Alabama, or anywhere else, your right wheel spins and the left one just sitting there like a rubber dummy. That's how she knew that car that drove away from there was a 63 Pontiac Tempest, because it was the only one that had that configuration with independent suspension and positive traction. See what I'm saying? Because she saw both wheels spinning and went over the curb. She knew which kind of car it was. You remember how she made that guy look like a fool?
Yeah.
But she's cool. But anyway, the long and the short of it was, that movie had a lot of lousy, bad language in it, but I liked it. It was a good movie, But anyway, the long and the short of it was, if you're spinning, if I've got a pickup truck on the lift out here, and I think a bearing is bad in the back, right? And I got me some stethoscope, mechanic stethoscope, and I'm going to listen to that, one of those. If I'm listening, if it's just spinning on the lift, the right one's going to be whirling up a storm while I got it in gear on the lift, I got Quincy or somebody up there in the, and so I'm listening over here, but that one's not turning. This one is, and that one's not. So how am I going to stop this one and make that one start turning? Because all of the differentials running everything over to the wheel on the right side. You've seen that happen. Got me? So I'm going to grab the park brake cable that goes to that right wheel, and I'm going to pull on that park brake cable, and it's going to stop that wheel, and it's going to force this one to start turning. That's what traction assist does. Although it does it without you doing anything. You give it the gas, it starts to spin, it ratchets a little bit of brake pressure into the wheel that's spinning and forces the differential to send torque to the other wheel. That's what that's all about. So this, you notice that this one right here has got some additional stuff on it. You got me? What they're showing there? And you got an isolation valve right here that closes off one from the other. See what I'm saying? And it's typically going to be going to the one that's on the right, because that's the one that usually spins. You get me? Well, my wife used to drive this Tempo, and she wore the tires off on the right side, because when you're parked on that paint stripe and you take off, she takes off kind of jerky, and she'd smoke the tires on that thing. And I rotated the tires. One time the guy at the tire store wondered why both the tires on the right side were worn smooth and the ones on the left were thin. All right. Traction control sometimes utilizes the powertrain control module. Up to 35 miles an hour. Beyond that speed, it reduces the torque as the wheels uses the powertrain control module. So what it does, if you're still spinning and you're going 35 miles an hour, the powertrain control module says, I'm cutting back on some of my fuel, I'm cutting back on some of my time, and I'm going to make sure that these people aren't staying into it so deep. These Lincolns right here had that traction assist on. There's a throttle body laying over there somewhere. It's got two throttle plates. It's got a secondary throttle plate that's above the other one. It starts to close that off if you get too rambunctious trying to spin the wheel. All right. It also controls ignition, emission, and fuel systems, and a whole bunch of other stuff that reduces engine torque. It assists braking above 35 miles an hour. So that's one of the things that the traction control does with the PCM. All right. There's your electronic control unit. They're all at various different places. You usually need to be under. If you see a Complicated looking piece of hardware with an electronic control unit on it and a block. It's got a whole bunch of steel pipes going to it. That's going to be your ABS. It's under the hood on her husband's truck. It's under, where is it at on the GMC? Anybody remember? Have you been under the GMC? It's right under the driver on the side of the frame. That's where it is on those. It's a big old chunk of stuff up under there. Got it? All right.
That old flag is back there in the back.
Yep, and they stick them all over the place, but you can see them, you know what I mean? Activate this anti-lock brake system. They perform self-diagnosis. They talk to the scan tool if they're working, if they will. And they store diagnostic trouble codes when a fault's detected. One of the things I like to do if I'm having issues with anti-lock brakes system and the controller is kind of low down like it is on some of the vehicles, I like to disconnect the connectors from it and see if there's water in them. Because sometimes you can actually blow in that connector. You may not even see any water in there, but when you blow in a connector and it splatters water all over your hands, that water will actually carry current and signals and make crazy things happen. All right, there's your hydraulic control unit. You've seen these before. This is a cutaway. It's got solenoids in it, right? And I've got some more of this kind of stuff around here somewhere. But basically, you'll see a lot of times you'll see the little solenoid, the metal part of the solenoid is sticking up like a little stem. And it's basically got a whole bunch of solenoid coils that go down over it when you put the thing on there. And I wish I could find, I should have had that in my hand when I started this session instead of having to go hunt it right now. But anyway, the long and the short of it is you'll understand what you're looking at when you get to that. All right, the majority of the hydraulic control units are constructed of a low pressure accumulator buffer chamber, high pressure accumulator dampner chamber, inlet port, outlet ports, inlet, isolation valves, outlet dump valves, hydraulic check valve, control valves, traction assist isolation valve. This is not a low cost thing. If you had to buy one of those, like for instance, seems to me like about 4 or 5 years ago I had to get a, and this is something else I wanted to say too. I was flushing the brake system on one of the oldest Chevrolet 2,000 mile Chevrolet truck we had with denatured alcohol. Delco used to have some stuff called D-Clean. It was purple. It came in a can. It was denatured alcohol, and it was made for flushing out brake systems, right? Well, I flushed the brake systems on his truck to get all of the fluid, nice and clean fluid coming out. And I used alcohol to do it. And then when I followed up, I put good clean fluid in it. That's fine, but then the hydraulic control unit died, and it started, the back brake wouldn't release. Because you remember that little to flush or not to flush test that I gave you guys? So if you flush it, your liable to break stuff loose is going to cause issues in there if you flush it with denatured alcohol. If you want to do this and you want to do it where you're least likely to have trouble, just keep pumping fluid through it until the fluid comes out clear. See where I'm going with that? Because you don't want that, because the brake fluid is not likely to cause a problem like the denatured alcohol was. One way or another, when I bought that hydraulic control unit to replace the one, and I bought one new from Chevrolet, it was a couple $100. It wasn't that bad, we popped it on there, got it bled out, everything's fine. He's driving it today. Well, there was another one, the one that the other truck, the one Gene drives, it needs one of these units. And I said, well, that's no problem. I'll just get one. We'll pop it on there. It's got ABS light on because it's got a problem down there with that unit. I don't even troubleshoot all that. The long and short of it is that thing is like $1,000 now. They've gone up. I don't know why they went up from 200 to 1,000 or whatever. They're super expensive. I think it was 850 or something. It's coming up on 1,000. Most of them combine the ECU and the HCU into a single assembly. Now the Little Ranger does not have a hydraulic control unit with a motor and all because it's only doing the rear brakes. Those systems are a lot simpler. You don't usually talk to them with a scan tool. You flash out the codes and you go after them with a little chart. On these other ones, you're going to scan tool them. I've also had one, you might remember in electrical, we had one if the ABS won't talk, or a lot of the times the ABS will get the signal from the sensor that is telling vehicle speed, and it will take that and it will interpolate it and send it up to the engine controller and the other stuff that uses the vehicle speed. The ABS unit goes down, you lose your vehicle speed signal to a bunch of other stuff. So keep that in mind. You always want to make sure you can talk to that, The components used in the electronic hydraulic control unit are similar to the one used in ECUs and HCUs, blah, blah. Usually easier to diagnose because the ECU half of the assembly contains nearly all the electrical components used by the ABS. Here's your low pressure accumulator. It's in the valve body, temporarily stores fluid purged from the wheels. It's normally empty. That pressure is also used to prime the pump. And at the end of the ABS stop, it's drained back into the master cylinder. High pressure accumulator is also located in the valve body. The valve body is right here. And it's got hydraulic fluid under pressure used to reapply. It fills when the anti-lock brake control unit module turns on the pump. Now, on some of these vehicles, like Ford vans, for example, there is a brake bleed procedure that has to be done with a scan tool. You have to hook the scan tool up, go in there and check, do bleed procedure in your husband's truck's like that, but it won't talk. And so, and I was telling him, I said, this thing's going dark on us, it's not good, you know. So anyway, you fire up that thing and you go run that pump, and it basically, when you're running the pump, it gets the air out of there.
I actually have another ABS to put on that truck too.
Yeah. Well, you can keep the can down the road for a while on that. Driven by a motor, provides the fluid movement under high pressure for the APS. See, it's a cool little motor here with these little, armature and stuff. They may create more pressure than demanded by the driver, so, the delivered fluid to reapply, see, it's got to produce enough pressure to overcome the pressure in a master cylinder. That's the reason the brake pedal comes up and can be felt by the driver. And on some of them, you can service the pump separately. This thing likes to fail. On a lot of the vehicles, this is a hard working part if you use it a lot. You understand what I'm saying? This is where the pressure comes from that makes your traction assist work. It'll turn that on because you're not going to be hitting the brake, creating pressure, so it's got to be able to produce its own pressure. Now, here's your component operation. Every ABS control wheel is monitored by wheel speed sensor, except on some of them, on the GMC. The output shaft sensor that's monitoring the drive shaft going back to the rear wheels, they assume that both of the rear wheels are turning if that, I mean, they just look at both rear wheels with one sensor, usually pickup trucks do. Cars, and some pickups look at all four wheels, but some of them don't, so be prepared for that. Wheel speed sensors are very close to the wheel speed sensor indicator. Some of the wheel speed sensor indicators have got little magnetic strips built into the bearing seal. Did you know that? And there's a little thing I got here on top of my desk. If you have an ABS problems and that particular little, that little colored part of the seal that keeps the grease in?
Yeah.
It actually has got some little magnetic strips in it. And if those things go bad, you can actually hold this thing up there and you can see the magnetism in those, and you can see if they've got some missing segments. You got to replace a wheel bearing on some of them. Now on your GM cars, you cannot replace that sensor without replacing, I say on some of your GM cars, you can't replace it like on our Oldsmobile out here without replacing the whole hub assembly. And I saw on a traction assist problem on Judy McClaney's vehicle. She actually has this Pontiac Montana, and she'd go to drive off and it would do traction assist and turn on the light when she was just driving off normally. She wasn't spinning the wheels or anything. And it had a wheel that was reporting 22 miles an hour when it was going 3. And so we had to put a bearing on that one. I actually wrote that up in a magazine article.
We, on my fiance's Buick, we replaced the hub assembly because it was going bad. Then it had a leak. The seal burned out, so we warrantied that out. And now it's having that traction control problems on that same wheel.
Yeah.
And I want to say it's that wheel speed ring.
Yeah, if you can find it doing that, have your scan tool be looking at it, and if you see it reporting a speed that's higher than true, then you'll know that you got a problem with that hub. I mean, that's the only thing that can cause that.
Dig into each specific wheel?
Yeah, you can actually open up the PIDs and have look at them separate, next to one another on the screen. It's really cool. And it's a pretty good idea to do that. All right. Wheel speed sensor indicators are connected to the hub. Now, if you're buying CV axles or if you're buying brake rotors, they're probably going to ask you if it's got ABS.
Mm-hmm.
It's really important that you tell them the truth about that, because I tell you what really happened. What happened one time, we wound up getting a hub. They didn't ask us, and it was for a Dodge Dakota. They did not ask us if it had ABS or not. They absolutely didn't ask that question. So because they didn't ask it, I didn't think to say anything about it. They just sent some hubs that didn't have ABS rings on them. And the students put it on there, I mean, I might have caught it if I'd have been there, I might not have, I don't know, but long and short of it, we put it back together. And did you know they drove that truck for 2 full days before that ABS light came on?
Wow.
I mean, and I was totally stunned by that, because I figured as soon as you went to pull off, it would tell you.
Pop up.
But we put both of the front ones on there, and so it's watching both of the front ones. And I don't know if it wasn't comparing them to the rear ones or what, but the long and the short of it was, when it finally did come on and we were checking it, I said, oh, we got wheel speed sensor issues. Look, these things aren't reading anything. And I'm over there looking, and I was like, huh, I had a sensor here and there was no pulse ring. So we had to replace the hubs. So I called the parts guy and gave him a hard time about it. He sent me a couple that had hubs and just took those back in trade or whatever. creates a magnetic field that generates AC voltage when the teeth of the wheel allow the sensor indicator to pass through it. If you got wire wrapped around a magnetic core and you got teeth going past there, you're gonna get this signal. This is the way it is, all right? Okay, that allows the wheel speed, the ECU to count the teeth of the wheel speed sensor as they pass, allowing the ECU to determine the rotation speed of the wheel. That ain't rocket science. Now this is we're getting really close to the end here. This is the G switch, right here. You see that G switch? This is mercury, right here. Well, let me put some more words on the screen. Detects vehicle movement. All right, now listen to this. On some four-wheel drive vehicles, it's used because all four wheels are mechanically linked when you're in four-wheel drive. That makes it possible for a lockup at any single wheel to cause all four wheels to lock up. You got me? So it needs to know if you're on a four-wheel drive, if you're moving or not, right? You notice this mercury right here, and you got basically, you got to be able to detect vehicle movement. And they've also got some sensors on some of these cars now that actually detect when you're sliding or when you're cornering or this kind of thing. And it's like vehicle dynamics that makes it SUVs and stuff less likely to turn over. You hear me? All right. Now then. All right, vehicles at rest are moving at steady speed. Mercury contacts all three terminals. I got this from Ford. This is a really good thing. Reference voltage is sent from the ECU through the center wire. The voltage returns to the ECU through the two outside wires. So you got two wires right here that are carrying that voltage. All three of those. This one here is fired up, and this mercury, because it's liquid metal, is actually carrying juice out there. Now watch what happens here. During deceleration, it starts decelerating. The inertia causes the mercury to move toward the front of the switch, breaks the contact between B and C. Got it? Look what happened. Is that cool the way I did that? Look here. See, it moved. You got it? All right, so now you've lost the voltage. It was here. You got voltage coming out here. You've lost that voltage, and you know you're stopping. You got me? You actually know. Now, what if you're extremely decelerating? It balls up right up in the front, and both of these other ones. See that? See how that is? That's cool. All right. If the rate of deceleration increases, the mercury is forced further toward the front of the switch, breaking contact between the center and B and C. So you're sending it out, but you're going to lose it to both of them if you decelerate hard enough. You got me? During acceleration, it moves back. So there you go. Now let's look at this right quick. Symptom, system, component, and cause. You understand what that means, right? You got a symptom, you're feeling something funky whenever you're stopping. The system, ABS system. Let's say that if you determine. Is the braking system, particularly ABS component, the ABS module, bad wheel speed sensor, oscillation valve. The cause of it is the coil's open or the sensor's damaged or something like that. Watch this, guys. Listen to what I'm telling you. This is important. If I turn the wheels and I get an ABS loss of wheel speed, or I get an ABS wheel speed sensor code, and then I turn them back straight again, look to the wires going to that wheel to see if the wire's broke, because you're constantly bending it every time you turn the wheel. I've seen that before. And it's be broken too, the little wire up there. You can usually see it with your naked eye. But if you've already put a sensor in there and the harness leading to the sensor is broke for whatever reason, you're going to have to verify the symptom, determine what, that's tough if you can't get it to do that. Determine what system on the vehicle will be causing it, isolate a component, determine what caused it to fail, and then when you're diagnosing it, you got to follow standard procedures to locate the clues. You got to be a critical thinker. That's what I was telling Venestrand this morning. You got to be a critical thinker. You got to think critically. And don't look for somebody to give you a silver bullet every time. Got me?